Does anybody?
Go ahead.
Good afternoon and welcome to this week's Security Seminar at Purdue University. Today's speaker is Dr. Dennis Moreau. Dr. Moreau is the co-founder and CTO of Configuresoft. Dr. Moreau has over 20 years of experience in evaluating, designing, and managing software systems. He is a specialist in the application of leading-edge technologies in complex problems within the IT management domain. Please join me in welcoming Dr. Moreau.
Thanks very much for inviting me to be here. Today we're going to be talking about some aspects of virtualization security and the characteristics not only unique to virtualization technologies, but unique to the ways that virtualization technologies allow environments to be managed and some of the things we have to consider with respect to security in that area. Just to facilitate doing that from the other side so I can see the same screen you guys see, I'm going to move this way. Try to go full screen. How's that working for you? Can you see it fairly well?
Yeah, looks good.
All right. My background is primarily computer science, primarily in distributed systems and systems virtualization with respect to massive amounts of data and visualization. So if you have any questions along the way, don't hesitate to interrupt me. I'll be moving pretty sprightly through the material, trying to do some introductory stuff, but I'm assuming you know a lot about operating systems and system software and to some extent security. Is that fairly consistent with you guys' expectation? Cool. So from our perspective, we're going to be addressing virtualization, the new concerns it introduces, resource sharing, how that changes those security concerns, what it means to couple both behavior, security posture, and the reactions that we have to have in virtualized environments, especially those environments that are deeply virtualized, more than one level of virtualization. We'll talk a little bit about security configurations with respect to virtualization and what kinds of tools you leverage to get a handle on the problems that we're describing. What can you do about it? So not just throwing grenades saying, here's a problem, but also pointing the direction toward what kinds of innovations would make a difference and help us make some headway against the problem. So classic virtualization, what we essentially have is hardware in the environment, guest operating systems, and these operating systems have configurations. If they're Windows, they have a registry, they have DLLs, they have APIs, they have applications. All the stuff you used to have to do on normal operating system environments, you still wind up having to do. But now they're co-hosted, and I've got another layer of technology being interposed. That layer of technology has configuration information associated with it. There are APIs. There are settings that determine the performance, the behavior, the security, and the availability of those systems. Those are settings that we're contending you have to pay attention to when you do virtualization. But there's some interesting interactions that accrue consequently. There's some good stuff that happens with respect to virtualization. If I virtualize my environment, I'm creating a level of abstraction and normalizing the interfaces that my operating systems have to see. That means I have less diversity. Less when I provision my operating systems. When I deploy Windows XP across a large environment, I've got less variation to worry about behind that layer of abstraction in order to provision things. So I can concentrate on doing fewer permutations so I can spend more time on those individual permutations doing the care and feeding of those particular permutations. So reducing diversity is a good thing with respect to security management. We get some degree of sandboxing. There's some degree of insulation associated with virtualization. It can prevent some sorts of exposure. It certainly isolates guests to some extent from other guests and from the underlying hosting environment. That is both a benefit and a challenge. We'll talk about that in a minute. Rapid deployment, it becomes much, much easier once I have a virtualized image to say, I want more of those in the environment, press a button and have lots more. That's also a benefit in allowing you to be more agile. It's a challenge in terms of having lots more things because you can do them on demand when you need them and you're not waiting for purchase order processing or someone to run down to CompUSA, right? In addition, you get re-imaging where that's appropriate. So if I decide this environment has changed in a way that I don't want, that I don't expect, and I want to get it back to the way I had it before, that's very, very easy. Where that's appropriate, hold that thought. we'll wind up getting an increased control over network activity because those extra layers of abstraction allow you to control behavior across those layers of abstraction. So you're able to tune things in just a little bit more interesting ways. You wind up getting some insulation for specific vulnerability types from exploits there, and you wind up getting an ability to do exploit analysis to be able to reverse engineer what malware is doing in controlled environments so that you can understand those better, draw conclusions from that in terms of how you should react, but also develop even counterattacks associated with this stuff. Now, virtualization accomplishes its magic using three basic fundamental characteristics. The first of the characteristics is insulation, creating a sandbox in which I insulate one asset from another so that that hosted asset, that guest operating system, believes it's the only guy on the box. To the extent that that's possible, then this guy can't break because you virtualized him. I can take a physical asset, move it to a virtualized environment, and not have it know the difference. That's the good side of insulation. The downside of insulation might be I've got agent instrumentation on that box looking for malware, looking for any spyware, looking for stuff. What can he see? Only what's in that box. Virtualize the guest, you virtualize the instrumentation, and to some extent the visibility you have into the overall environment unless you do something else, something specific to virtualization. Independently, there's lots more sharing. The reason you virtualize very often is I want one piece of underutilized iron, one big fire-breathing box that had a 5% utilization, to get used a lot more efficiently. Good news. But I am also causing the hosted environments, the guests that sit on that piece of iron, to now share host bus adapters, caches. I'm having them share processors, sharing NIC cards, sharing all sorts of stuff, and that sharing has an effect that affects security posture and coupled behavior. We'll talk a little bit more about that subsequently. Finally, dynamics. When it's very easy to provision new stuff based on need, based on demand, I'm going to do that. And when I do that, I'm changing things. Not only am I changing things in terms of spinning up new things when I need them, I'm tearing down old things. I'm also able to, through dynamic migration or vMotion and the more proprietary technologies, take an asset here and move it over there while it's still running. So my ability to track assets based on MAC addresses and IP addresses and all sorts of contextual stuff that you can assume when things are static and have a fairly fixed relationship, all of a sudden need to be able to be a lot more flexible in a more dynamic environment. Virtualization infrastructure, the plumbing under it, never has been perfect. Very unlikely to be perfect. For example, here is CVE 2008-1944. So, serial number for vulnerability. It's in 2008. It's number 1944 for that year, right? And in this particular vulnerability, what we have is the possibility of executing arbitrary code in an underlying host from a guest. If I could exploit this vulnerability, and this one I believe is on Zen, right? I have a guest exploiting a vulnerability, taking over the underlying host. What's the implication of that? If I own the host, what happens to all those other guests? So did I just couple, to some extent, the security posture of all of those guests by simply co-hosting, right? And of course, you get from that all the affected platforms, which happen to be just about all of the Zens. More interestingly, coupling happens in the environment as well. Here we have the University of Michigan exploit, something that came out, I believe, also at the beginning of this year. And the idea here is that I've got an asset. I decide I'm going to dynamically migrate it from one host to another. And because I'm dynamically migrating it from one host to the other, if I insert a man in the middle, there's nothing keeping me from altering the bits in flight, so that the virtual machine that started here is not the virtual machine that's executing over there, right? All of a sudden, you see real impetus behind the recommendation that we isolate the vMotion or dynamic migration LAN from the transactional LAN, and we isolate that from the application-specific local area networks. All of a sudden, virtual machine hosting environments have lots of physical NICs or lots of VPN configuration to separate network traffic so that it's not very easy to get exposure to the ability to do this, right? We'll go into a little more detail subsequently. So the point, virtual infrastructure, whether it's at the application virtualization, the server virtualization, the storage virtualization, or the network virtualization level, has never been perfect in the past. It isn't perfect today, and it's very unlikely to be perfect into the future. What that means is that we have to pay attention to the controls with every new introduction of those layers of technology into the environment. We have to pay attention to Security controls in particular, and almost all of those are articulated through APIs where we can get configuration settings about how are these things configured in the environment. They also create a degree of coupling. Where sharing occurs, some interesting things happen.